All right. So I said the other day that I'd run through some examples and of inch fit calculations and stuff, just so you can see it from start to finish. So I put this little presentation together. I was going to do it, literally by hand. I was going to do the calculations and everything and kind of show you a picture of the sheet as I'm writing it out, but that didn't play out because of the camera and all that good stuff. So I kind of did it this way with PowerPoint. The the nice thing is you'll have this also, and I've kind of worked through it. So let's go ahead and get started. All right. So the first example we're going to do is an RC4 fit. So by the way, I've done the 3 fits that are used in the engine problem, RC4, RC7, and LT1. So these are the examples that I've done, although I have changed the basic size. Okay, so the first one we're going to look at is an RC4 fit. Okay, and you can see on the left hand side, this is just a diagram of what we're trying to solve for. All right, so the fit means that we have a shaft and a hole that are designed to fit together. We're looking for the shaft upper limit of size, ULOS, and lower limit of size, LLOS. So we're looking for those 2 numbers. The shaft, remember, is also called a positive feature, right? And then we're also looking for the hole dimensions, which is going to be the upper limit of size for the hole and the lower limit of size for the hole. And the hole, again, can be referred to as a negative feature. Okay, so that's basically what we're trying to find. And we're given that we want to create this fit as a running clearance fit of grade 4, so an RC4 fit. Okay, so we're gonna do this for a 1/4 inch RC4 clearance fit, RC4 fit. Okay, so the basic size is going to be 0.25 inches. And we're going to find the shaft and hole dimensions for this. All right, so let's get started. So first, from the table, all right, this is from the RC4 table or RC tables that are in Canvas. We're going to find the RC4 column, which is right here, and then we're going to find where 0.25 would be situated, and that's on this row. And so we come across and we see these 6 or 3 pairs of numbers: the clearance, the hole, and the shaft deviations from the basic size. That's what they're called, deviations from the basic size. And that kind of gives away what we're doing here. Now, I want you to remember, it's very important, these numbers are not the correct numbers. None of these 6 numbers are the correct numbers. And in fact, we need to shift them, adjust them, so that they have the correct decimal places. So these are in thousandths of an inch. So 0.9 becomes 0.0009. 0, of course, stays 0. 0.5 becomes 0.0005, and 1.1 becomes 0.0011. All right, so that's our transformation there. And let's go ahead and get started with the calculation. So we start with the basic size is 0.25. That's what we get from the definition right up there. Okay. So in the basic hole system, which this is, right, because there's no S on the end of this, so this is the basic hole system. In the basic hole system, the basic size is equal to the minimum hole. So now we have one of our 4 numbers right here. The basic size is the minimum hole right there. All right, and so the minimum hole is 0.2500. Now moving on from there, the maximum hole is going to be the basic size plus 0.0009. Now, where did I get that from? Right in the table, right? The maximum hole is the basic size plus 0.0009. That's what that plus means, right? So we take our basic size and we add 9/10 of a thou, and we get 0.2509. And that's the maximum hole. So look at that. In 4 steps, we have, or 5 steps, I should say, we have half of the problem solved. We have all the numbers for the hole. We have the upper limit of size, and we have the lower limit of size. All right. Now moving on, the maximum shaft is equal to the basic size minus 0.0005. Again, where did I get that from? Right down here, shaft minus 0.0005. Now, if you're wondering, well, how did I know whether this was the maximum shaft or the minimum shaft? Well, you know, to be honest, it doesn't really matter. If you make a mistake and make this the minimum shaft, the number is still going to be the same, but it's going to be larger than the maximum shaft, and so then you'll know, whoops, the max can't be less than the min. So, all right, so we can do this. The max shaft is equal to 0.25. Again, this number minus 0.5 of a thou is 2495. And then min shaft is the basic size minus 0.0011. Again, we got that right here. And so the min shaft is equal to 0.25 minus 0.0011 is 2489. And folks, we're done. All right. So those are the four numbers that we need for the hole and the shaft dimensions. Those are the numbers right there. Okay. Now let's do this again. We'll move on to an RC7 fit. All right. You'll find that it's going to be the same. All right. So we start with, let's do an example of a diameter 1 RC7 fit. Okay. So find the shaft and hole dimensions. First, we find in the table where the R7 table, we find the column down and we read across where 1 is the nominal size, and we get these 6 numbers. All right. We transform those numbers in the correct decimal places. The basic size is given as 1 inch. And so again, in the basic hole system, the basic size is equal to the minimum hole. And so therefore the minimum hole is 1 inch. All right, so there's one of our 4 numbers done. The maximum hole is equal to the basic size plus 0.0020. Where to get that from? Right there, hole, read down 0.0020 after we convert it. So therefore the maximum hole is equal to 1 plus 0.0020 or 1.0020. All right. The maximum shaft is equal to the basic size minus 0.0025. Here's 0.0025 right there. So therefore the maximum shaft is 1 minus 0.0025 or 0.9975. And the last number, the minimum shaft, is equal to the basic size minus 0.0037, which comes right there. And so the minimum shaft is equal to 1 minus 0.0037 or 0.9963. And those are our 4 numbers, boom, 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 for the hole and shaft. And there they are. All right, let's do one more. The other one in your engine problem is an LT1 fit. This is a transition fit, okay, which means that we expect to see a little bit of clearance and a little bit of interference through the range of sizes, right? And when we talk about range of sizes, we're talking about these range of sizes. Remember that these numbers here, let's go back one, these numbers that we're calculating are the acceptable range of sizes for the shaft and the hole. So as long as we produce a shaft within this range of sizes and a hole within this range of sizes, we have good parts. Okay. So in a manufacturing process, if we have a bucket of shafts and a bucket of holes, and we reach in and grab out a shaft, we don't know what size we're going to get, other than to say that the shaft that we pick out is going to be within this range. And same for the hole. All right. So when we talk about a range of sizes, it means that, you know, throughout the whole range of fits that we could have for a properly manufactured shaft and hole using an LT1, this is what we're going to get. All right. So for this example, we'll do a 0.375 LT1 transition fit. All right. So we find the shaft and hole dimensions. First thing, let's go to the table. Here's the LT1 column. And we read across from the 0.375 nominal size range, and we get these numbers right there, which we transform right there, moving the decimal place. Note that in the shaft size, we now have a plus and a minus. In the other ones, if we go back real quick, sorry, we have minuses on the shaft side. Why? Well, because in all these cases, the clearance fit, the shaft is always larger than the hole. So these have to be minus or less than the basic size, which is the minimum hole. Now, if we go here, well, now we could get a situation where the shaft is larger than the hole. That's a transition fit. All right, so the basic size is 3750. We're still in the basic hole system, so the basic size is equal to the minimum hole, and so the minimum hole is 0.3750. One done. The maximum hole is the basic size plus 0.6 of a thou. We get that from right there and right there. So the maximum hole is 3750 plus 0.6 of a thou is 0.3756. The maximum shaft is the basic size plus 0.2 of a thou. And there's our plus right there, or there. And so the maximum shaft is 3750 plus 0.0002 is 0.3752. And the minimum shaft is the basic size minus 0.2 of a thou. There's the minus sign. And so the minimum shaft is 3750 minus 0.2 of a thou, or 3748. All right, and so this gives us our final answer for the shaft and the hole. Now, before we move on, let's just take a look at this. So, the shaft, if we produce a shaft that has a diameter of 3748, it will always be smaller than any hole that we produce. Right, 3748 is always less than 3750. But if we produce a shaft that has a diameter of 3752, it will create a slight interference fit with any hole produced that is less than 3752. So 3750, interference fit. 3751, interference fit. 3752, that would be what we call a line fit. Okay, so we could have a range of interferences from 0.2 of a thou, 1/10 of a thou, or a line fit in this case, because this is a transition fit. All right, so I hope that helps. I'll post this and the presentation on Canvas, and I'll send you a little announcement that it's out there. All right, thanks. Let me know if you have any questions. Bye.